Hello everybody, this is our presentation about radiation protection. My name is Matan and my partner name is Netanel. Let's talk about radiation.
So what's the problem? The problem is radiation. Radiation is waves or subatomic particles that transport energy to another entity. The radiation can be dangerous to humans and decrease the risk of cancer and other diseases. The problem with radiation in space is that space does not have a magnetic field like Earth that reject the radioactive atoms. As you can see in the picture in right, the radioactive atom has the energy and the radiation that we pollute.
This is our brainstorm about radiation protection. As you can see, we analyze it for different kinds. In our presentation, we decided to talk about the solutions and focus on the material solution.
So what's the solution we have? The first one is use new materials that in the other slide we can explain about this. The International Space Stations that reject the atomics of the radiation to get to Earth. Instruments that measure the radiation like the picture in the right. And the most advanced protective suits today that protects about the astronauts from get a big amount of radiations. As you can see in the picture, the astronauts building the suits that protect on them.
The material solution. There are some materials that are potential candidates for radiation shielding. First of all, we have the polyethylene. The polyethylene has a high amount of hydrogen. It's really cheap to produce in big amounts, but the problem is it's not strong enough to build a large structure like an aircraft. The second candidate is BNTs. BNTs is nanotubes made of carbon, boron and nitrogen, with hydrogen interspreads throughout the empty spaces between the tubes. It's really strong even in high heats, so it's strong enough to build a large structure like a spacecraft. The third option is yarn out of BNTs. It's very flexible. It can be woven into the fabric of spacesuits for the astronauts. At the bottom of the page you can see the picture of BNTs with the boron, nitrogen and carbon all together.
So how we applying the BNNT materials in places? The BNNT is still development and testing. It's a new material. However, it has the potential to be our key structural shielding materials in spacecraft, surface vehicles, astronaut suits and other stuff that connected to space.
This is our sources list. As you can see, we try to work from NASA to get reliable information about the radiation protection in space. Hope you enjoyed and have a great day. Thank you.